Good evening all. Now I am going to explain about transformer and its working principle. Okay, first the definition of a transformer is a static device which transfer power from one circuit to another circuit by changing voltage levels and current levels. Power and frequency should be constant. Okay, now see here, this is a transformer. Okay, which transfer power from, this is one circuit, this is another circuit, right? Transformer which transfer power from one circuit to another circuit by changing voltage levels and current levels. Power should be constant. That means, for example, primary side is 230 volts, secondary side is 115 volts, right? This is high voltage, right? And this is low voltage, right? High voltage side current will be, let's assume 10 amperes. Secondary side current is, low voltage side current is high, that is 20 amperes, right? 23 into 20, 2300, okay, volt amperes. VA rating 115 into 20, that is again 2300 volt ampere. Now see here, transformer is a static device which transfer power from one circuit to another circuit by changing voltage level and current level. Okay, power should be constant. See here, input side power is 2300 volt amperes, that is kVA rating. Output side also or secondary side also power rating is constant. Okay, when voltage level is high, current level is low. When voltage level is low, current level is high. Okay, transformer is a static device which transfer power from one circuit to another circuit by changing voltage level and current level. Power and frequency should be constant. Next, coming to some basic definitions. Primary winding. Okay, this is the primary winding, this is the secondary winding. Okay, the winding which is connected to the supply voltage is known as primary winding. Okay, next, secondary winding. The winding which is connected to the load is known as secondary winding. Okay, this is the secondary winding. Okay, primary winding is having N1 number of turns, secondary winding is having N2 number of turns. Okay, here EMF will induced on primary winding is E1, the EMF induced in secondary winding is E2. Okay, now we will see the working principle of a transformer. Now see here, transformer works on the principle of Faraday's law of electromagnetic induction and mutual inductance. That is the working principle of a transformer. Now see here, mutual induction is nothing but, now see here, when AC voltage is given to the primary winding of a transformer, okay, it will produce a flux phi in the transformer core. Now see here, this is AC voltage V1 is given to the primary winding of a transformer. Because of this AC voltage, current I or I1 is flowing into the primary winding, right? This current will produce a flux phi in the transformer core. Okay, the produced flux which links with the secondary winding also, right? Okay, now see here, this primary winding is having N1 number of turns and secondary winding is having N2 number of turns. Okay, now we will discuss how this EMF is induced, E1 and E2. Now see here, according to Faraday's law of statically induced EMF, okay, this is primary coil, this is secondary coil, right? Here we are giving AC supply is given to the primary winding, right? This AC supply will produce a current, right? The current will produce flux phi, right? Okay, now see here, whenever current in coil changes, this coil is having N1 number of turns, N1 into phi is nothing but flux linkages. Okay, whenever current in coil changes, flux linkage in the own coil changes, hence EMF will be induced. That EMF is known as self-induced EMF. Okay, whenever current in coil changes, flux linkage in the own coil changes, hence EMF will be induced. That EMF is known as self-induced EMF, that is E1 is equals to minus N1 d phi by dt. Okay, next, mutual induced EMF. Now see here, whenever current in one coil changes, okay, the produced flux in the first coil is also linked with the neighborhood coils. Okay, whenever current in one coil changes, okay, flux linkage in the neighborhood coils also changes, hence EMF will be induced on the secondary coil. This EMF is known as mutual induced EMF. That corresponding property is known as mutual inductance property. Based upon this property only, transformer is working. Okay, because of this induced EMF, current I2 is flowing in on the secondary side, that is E2 is equals to minus N2 into d phi by dt. That means, see here I can explain the working principle. Whenever AC supply is given to the primary winding, okay, it will produce a flux phi in the transformer core. Okay, the produced flux which links with both primary winding and secondary winding, right? Okay, because of this flux N1 into phi, EMF will be induced on the primary winding. That EMF is known as self-induced EMF. That is, whenever current in coil changes, flux linkage in the own coil changes, hence EMF is induced. That is self-induced EMF. Now see here, whenever current in one coil changes, flux linkage in the other coil changes, N2 into phi, right? Hence EMF will be induced. That EMF is known as mutual induced EMF. Because of this induced EMF only current I2 is flowing on the secondary winding. Okay, that is about working of a transformer. Now see here, from this equation I can written as E2 by E1 is equals to, E2 value is minus N2 into d phi by dt, E1 value is minus N1 into d phi by dt, right? That is E2 by E1 is equals to minus N2 into d phi by dt divided by minus N1 into d phi by dt, that is E2 by E1 is equals to N2 by N1. Okay, from that relation the conclusion is the induced EMF is directly proportional to number of turns. Okay, when induced EMF is high, number of turns will be more. When induced EMF is less, number of turns are less. Okay, next some basic definitions. Step up transformer. Now see here, assume here E1 as 230, E2 as 115, right? 230 is transformed into 115, right? That is voltage level is reduced, right? That is a step down transformer. That is, when E1 is less than E2, those transformers are known as step up transformers. That means E1 value will be 115 volts, E2 value is 230 volts. Voltage level is increased, right? That is a step up transformer. Next, step down transformer. When E1 value is greater than E2, those transformers are known as step down transformers. This is in terms of induced EMF. Suppose in terms of turns, when N1 is less than N2, those transformers are known as step up transformers. When N1 is greater than N2, those transformers are also known as step down transformers. Okay, next, transformation ratio. Okay, it is defined as the ratio of secondary induced EMF to the primary induced EMF and secondary number of turns to the primary number of turns. For an ideal transformer, ideal means we are expecting that kind of performance, but practically that is not possible. Okay, for an ideal transformer, input power is equals to output power. Practically that is not possible. Okay, right? Your input power is nothing but V1 I1, output power is nothing but V2 I2. That is V1 I1 is equals to V2 I2. From this equation, V1 by V2 is equals to V1 by V2 is equals to here I2 by I1. That is equals to E1 by E2. Okay, in terms of transformation ratio, K is equals to E2 by E1, that is equals to V2 by V1, that is equals to N2 by N1, that is equals to I1 by I2. Okay, next see here, transformer action based upon electromagnetic induction. Already this point is discussed, right? Okay, see here, in case of transformer, two windings are magnetically coupled and electrically isolated. Now see here, these are the two windings, right? Two windings are magnetically coupled because flux will pass from primary to secondary, right? That means two windings are magnetically coupled, electrically isolated. Electrically isolated means there is no wire connection. See here, there is no wire connection from primary winding to secondary winding. That means in case of transformer, two windings are magnetically coupled, electrically isolated. Okay, in case of transformer, frequency should be constant. Okay, in case of transformer, there are two types of losses are there. First one is iron losses, second one is copper losses. Iron losses are constant losses, whereas copper losses are variable losses. Okay, remaining topics will be discussed in next class. Thank you all.